news hour now. So I'm Rich Bonneau. I'm half in the computer science department and half in the bio department. Computer science department's at Courant, and I mostly am a computational biologist and computer scientist, and this is my midlife crisis project. And this is something new that I've been doing for the last couple of years. This is Josh Tucker, who's in the political science department at NYU, and actually used to be a faculty member here in the Woodrow Wilson School and also at poli-sci department. And I'm going to talk to you today about the NYU Social Media and Political Participation Lab, which is essentially well, I'll go through who we are, what we want to do. I'll talk about infrastructure, and when we get to data and some of the problems, I'll hand it off to Josh to talk about essentially the research question and what we found. The talk's a little bit more aimed at what questions we're trying to answer, and what we found recently, and some of the topics that we've been aimed at. And if people want to get into methodological details, stop us, and then we can go through things. And then after that, we'll talk about a few examples of analyses and some challenges that are sort of associated with some of the papers we're pursuing here. But basically, the goal is we want to understand political participation, and we want to do this for a few reasons, but one really key reason is that essentially social media gives us a window into individual behavior, and political participation is one of the most carefully tracked individual behaviors that's out there. And this political participation could involve voting and registering with parties. It could also involve, and we're interested in participation in disruptive political events like protests and things that are. So we're interested in a variety of social media effects on a variety of political participation types, and really we want to look at social media as a source of variables which can predict participation, but we are not completely beholden to just this thing. This is the main thing we're trying to pursue, and there's a bunch of other things that have come out as we try to mentor a growing, unruly group of grad students that span a handful of departments. We want to essentially study politics, so there's a lot of things that we're doing that don't necessarily involve participation. Josh will talk to you about ideology and essentially ideology's effect on people's rates of communication with each other. We also want to, one of the key things that I think that we want to differentiate ourselves from other people who use social media is that when it comes to political participation, there are lots of additional pieces of data, and so we can synchronize with survey data, we can synchronize social media data with across platforms, and we can synthesize that data with things that we can get from a person's name or the geotags of their tweets, so we can estimate or get fairly good information about what political parties they've registered with, the price of their home, a number of other things that can allow us to sort of correct for the demographic problems or imbalances in the social media data. So there's a lot of things that we can do because our questions are political science that you might not be able to do if you were trying to track the incidence of flu or the popularity of e-cigarettes or some of the other things that we're peripherally involved with. And then lastly, we want to make sure that a lot of what we have to do, and some of what I'll tell you about, is intellectually less stimulating than maybe other things that we do, and so we want to share our tools, make all of our code open source, so some of this sort of back-end stuff that isn't most exciting data science or political science or computer science, some of that stuff we'll just share the code instead of talking about. And so we want whatever the infrastructure we need to accomplish these goals, we want to share that. And the sort of reality of the social media lab is that we have computer scientists, social scientists, political scientists, who all have their various strengths when it comes to the quantitative aspects of the project. So the data manipulation is no problem for the computer scientists. The statistics and some of the some of the more advanced modeling concepts are very clear for the political scientists who are trained in that very well. The machine learning is obviously in the wheelhouse of the computer scientists, and then the social psychology guys have a handle on theories that involve individual behavior and how emotion and various other things affect decisions. So there's a lot of complementarity in the people that are involved. So again, we have 2 political scientists, a psychology professor, and then I'm joint computer science and biology. So I have a strange mix of disciplines. We have 2 software engineers that are funded full-time by an NSF grant, and now by essentially a diversity of methods. We have postdocs supported by the growing data science department at NYU in Courant. So we have the Center for Data Science, and that's funded by the Sloan and Betty Moore Foundation, a grant to build that department, and also to sort of, to hire postdoctoral fellows and data scientists to work as part of that center. So we have some people that are associated with the data science effort at NYU. And then we have essentially this gaggle of PhDs and undergrads who, Josh will tell you, are working on a very large number of different papers. But the idea is that these people work to build infrastructure that make the technical barriers to working with this data very as low as possible without sort of sweeping over key details, so that these people can focus on the modeling, the stats, the demographics, synchronizing with surveys, and other things that the political scientists are ideally trained to do. So some other key people, so I'm here. I'll talk a little bit. Josh is there. Jonathan Nagler's one of the other PIs on the grant that sort of started this, and he is a political science professor focused on methods, and that's Jonathan Jost, or John Jost. He is a social psychologist who's done a lot of work on ideology and social justification, systems justification theory. And so the idea was to bring some poli-sci theories together with social ecology theories to see if we could come up with next generation theories for political participation. And I'm just sort of the guy to make things work. And so before I start and hand over to Josh, I'm going to give you just a teeny background about where I'm coming from and why I'm interested in social networks and why I'm interested in political participation. And so this is the sort of thing that I typically learn when I'm not involved in SMAP. So a lot of my lab is devoted to learning regulatory networks from genomics data, from high throughput biology data. And there we have, instead of elites, we have things called transcription factors. They control other genes, and we end up with models that have many, many thousands of components, many target genes being controlled by many thousands of other genes. One of the things here is that even though it's expensive, we can do lots of perturbations, and we can do something called genetics, where we actually remove system components and see what happens. Biological systems are also very different in that they self-assemble, and so I can make a copy of a 100,000 component system that's in a similar state to another one, and I don't think there's a parallel in other complex systems. So this is interesting, but it's not really relevant to social networks. But the things that I think are relevant are that many of the approaches to dealing with social networks treat all edges in a social network as being essentially static. There might be weighted edges based on the number of messages that have passed and things like that, but in the end, these edges are dynamic. We know that these people who are in social networks have patterns. And there's an analogy to how we deal with different cell types in biology, and some of the methodologies that we use to learn networks pay attention to the fact that different transcription factors are on at different times. And then there's also another analogy, is that because Twitter is longitudinal, we can take advantage of essentially attempts to model these regulatory networks in biology as dynamic events. I think there's going to be a lot of overlap there. And what I'm going to talk to you about today, and what Josh is going to really talk to you about, hasn't got to this level yet. This is where I hope to take things. And when I talk about the infrastructure, I'll actually point to a thing that's got me really worried, that is a huge barrier, and that relates to the fact that a lot of these data sets are coming from corporations, and that leads to limitations on how we access the data that are inhibiting our effort to sort of do some of this stuff. Yeah.
One question about your analogy. So I'm not a biologist, so this is more of a question. Certainly a social network is not a closed system. There are like exogenous factors that can affect political, reading the newspaper, for example. But now the biological system, is it closed or other exogenous factors?
Certainly not, yeah.
Okay.
So you have about 20,000 different bacteria living in your colon right now, and they're talking to your immune system more than your immune system is talking to itself.
Mm-hmm.
So, so depending on what you just ate, that's the newspaper, I think, what you just ate.
Got it. Thank you.
But in the end, so that's the cheeky answer. But in the end, there are some aspects that you can treat as sort of isolated models. So there is a degree to which the system is changing over an evolutionary timescale. So Homo sapiens is not going to change in any great way over the generations, over my career, because I am one generation. So by definition, it won't change until sort of, I've died many times over. Okay. Now social networks change extremely rapidly, and so that is one difference. I think really the only two differences are how do we deal with model selection, a vast possibility of hypotheses and some domain knowledge. How do we do sort of structured model selection, dynamics, and then essentially this idea that users and edges are relevant under different scenarios or different topics or different times or conditions or patterns in the day, circadian rhythm. These have analogies to cellular constructs. But the networks themselves are definitely very different things. So I'll just set up what we've done to facilitate getting a bunch of political science and social psychology students working with this data. And really the things that we've done are, in addition to just sort of educating people on how to use computational tools of various types, we've built tools for collecting and storing Twitter data so that if people give us essentially outlines of a query in the form of keywords or in the form of users or topics that they want to pull down, we can use various forms of the Twitter API, or we can use various tools to scrape Twitter and Facebook data and other types of social media data and store it in the database so that there's at least the basic foundation for scientific reproducibility. The database is there, it's backed up properly, you're not going to lose the data, and all the metadata about where and how the data was collected is stored. We have tools to interact with this, so we have a SMAP Lab R package and a SMAP Lab Python package, and I'll give you the links to that. They are babies. There's a lot of stuff in there, but our vision for what these will evolve into is far from complete. There's a lot of things we really want to do on the learning side and the network side that are just getting started now. Tools to interact with Facebook data are, we've really focused a lot more on Twitter data, just given the accessibility and the fact that Twitter data is essentially much more public than Facebook data. But for interacting with the public Facebook pages and the aspects of this that are open to external queries, we have our tools for dealing with that. One of the things I'm really interested in is using the data and models built on the data to decide which messages to code, which pieces of text or tweets or Facebook posts to go in and manually label. So, and putting that into an iterative process to actually facilitate active learning and some research into active learning in this context. In that regard, we have ways of automatically building out things for Crowdflower for annotation, and we have our own homegrown tweet coder that we use to facilitate undergrads coding this. And so we are actively exposing NYU undergrads to disgusting Twitter messages, and that's a side effect of this. But we're doing as little as possible. Okay, so this is an overview of the overall structure. There's one thing that I didn't put in here, which is the dashboard. So as these collections are accumulating, it's a lot of data. It's coming in very quickly, and so we have sort of a web page that tells us what collections are ongoing and how bad are we, how dire is the situation with respect to how much more disk space or storage we need to buy or finagle from the university. But here are the major sources. So Twitter, Facebook, there are plenty of other social media sources that aren't those two, but those are the two major ones.
Do you worry methodologically that the Facebook feeds you get are going to be self-selected because they're the ones that are public rather than privately tagged?
You can.
Yeah, I mean, to date, what we've been using Facebook for is for studying elites and studying organizations.
Yeah.
So I mean, and
So they're
so it's
intentionally going
exactly
public,
what we
yeah.
want. And in fact, the selection bias there is much lower, right? Because there's an incentive for the elites and the organizations who are sort of building protest movements. They want to be online. They want to
Yeah.
be public. I mean, the nutshell of the data availability is Twitter is free in real time,
Mhm.
but going back in time until you have an agreement and large-scale agreements between academic institutions and Twitter is very expensive at the moment.
Yeah.
So it's free in real time, and almost everything's public. Facebook, oddly enough, the vast majority of it is private, and you can't touch it unless you're working inside Facebook, which brings up a whole other set of issues, but you can go back in time. So it actually does and give you some synergies, and I'll show you a few. Actually, in this talk, I'm not going to show the Facebook stuff, but I can talk more about that later if you want to think. But you do have this ability to go back in time, which is kind of interesting.
Yeah. So this slide, basically, I'll just go through it. So we get these various things. So the streaming API for Twitter, or scraping all of the relevant public pages. This goes in. This is done after a SMAP user initiates a project which has associated with it all the parameters of a collection. And so typically this will be keywords and public pages that are identified. Okay. Now there's plenty of other things going on. There's survey data from YouGov. There's all kinds of other social media outlets that various countries use, and there's lots of options for this, but we're going to focus on this today. This goes through the query, through the filter on the streaming API, into what right now is a MongoDB database. This is the SMAP database. There's a lot of discussion about where to go from here as this thing gets to be. Who's seen Ghostbusters? So, there's a thing where the guy from the EPA says if you turn off the ghost collector, it'll cause the apocalypse, and he says, anyways, this is the ghost collector. It's filled to the brim with as much data as we can afford to collect, and it's getting worse. So this then is accessed by our two tools, and we have public versions of these, and the private versions are built so that our grad students don't have to think a lot about a lot of these interconnects. The tweet coder and Crowdflower then, of course, feed back into the modeling and machine learning methods. And we've had a few examples where we've used the machine learning to then suggest which tweets get coded, and that's one of the things I'm very interested in. Another sort of research topic is, given the model, what parts of the network do you want to complete so that you can do essentially network inference? What are the active portions of the social network? When are they on? How do you predict users' sort of receptivity to a message and things like that? I think those are all possible. And here, instead of using the streaming API and getting as much data as you want, or close to it, now you have to use the RESTful API or the APIs where you actually put in queries and say, I want this user, I want this tweet, I want this whatever. And you don't get many of those per hour. And so we're extremely bandwidth limited here. And these companies have internal research devoted essentially to marketing and advertisement. They don't have, or we have yet to really get a sufficient access to this to do a lot of the research things that we want to do on the network side.
So
And I don't think we're alone in that.
I was just going to ask, how big is the database these days? Or
We currently have 3.5 billion tweets in our various collections. I'll show you some of the collections a little later on in the talk.
so you guys are talking terabytes, or
It's less than 20 terabytes.
Yeah.
Okay.
Yeah, it's about by like 1%.
Okay.
And then it'll fill up tonight, and we'll have to go to Best Buy and buy like 2. Anyways, who knows?
Got it.
It's not.
It's 20
enormous
terabytes.
data.
And
Right.
one of the things that supports us is that our central IT at NYU is amazing, and so there is a giant high performance computing resource in Abu Dhabi. There are 2 very large compute resources there, and so we have an agreement with them for archiving the data, and so the servers that we have to just study or have to hold the collections that are being actively accessed, and everything else we can push to central IT, and they're extremely supportive there. That's something that really lets this work, because some of these collections actually get to be very large. So it's not that big, but for a single instance of a not parallelized database, it's bursting at the seams, and the next generation will be some much cleaner way of parallelizing this. And these are all essentially JSON records with metadata stored in various ways to keep us from having to access the metadata directly from the JSON file, which would be slow. Okay, and there's a lot of basic things that we need to do where we just need to figure out how to do them quickly. Not extremely exciting, but not trivial either. So essentially queries based on time, content, language, geography. Retweet networks, this is the thing that's the hardest to do. How do you take a corpus of tweets and grow out the retweets surrounding it? It takes time, it takes 1,000 fake Twitter accounts, it takes, whatever, it takes some cleverness here. And these are the things that we can estimate. These are the things that we are getting better at estimating. user and edge activity, ideology, Josh will talk about, and topic diversity and topics, Josh will talk a little bit about that. So instead of talking about that, I'm going to get to the point where I can hand it off, because I think I'm taking a lot more time than I meant to. So active learning, this is if we have rare topics, if we have some classification or coding that we want to do with machine learning of various types, we often get to the point where we have extremely rare classes. And so using topic modeling, machine learning to actually identify or attempt to predict which tweets fall into these rare categories and then sending those to be manually coded to increase or to improve our class imbalance is one of the things that I think is really neat. It's not that difficult. There's a lot of recent theory on active learning to show why it's not a bad thing to do. And so we've been able to do that. And we've had success with that. Josh, I'm not sure if you're going to show much from that. I think he'll show just the whole thing after we've gone through a few rounds of that. I'm going to, I think, just hand it off to Josh. Let's see. So this is, user characteristics that we're interested in. One of the main ones is, did you participate in a protest or did you vote? For this one, there's actually surprising enrichment for geocoded tweets in people who are in protests, because they're more likely to be using a mobile device, which jumps the proportion of tweets that are geotagged. They're also more they're also more technically, they're more, I think, interested in showing photos, giving evidence that they were there, and actually having their tweet geocoded, whether consciously or not, is some aspect of that. So geotag tweets, there are other things we can do. So often users declare or accurately say what their first and last names are, as well as their city and country. There's actually a low rate of lying on that for real non-robot Twitter users. Photos, text, and the social networks these people are in all give us various aspects of squaring away who's actually at a protest.
You mentioned YouGov earlier in survey data, but here you're talking about essentially estimating participation based on only the Twitter.
In this case, yeah.
Data.
Yeah.
Okay.
Yeah. I'm sort of mixing a few projects together. Sorry. I'm going to pass it off to you really quick. So this is SMAP-R is the public SMAP-R toolkit. SMAP-B is the Python library. And the SMAP toolkit, these are all things that you can get if you go through our website, I think. And I know that you can get it through our SMAP NYU GitHub account, which just is a giant unholy dump of code at this point. It's actually reasonably, it's got documentation. We ruined a PhD month to document this. All right, so I'm gonna actually let Josh take us through some real examples. There's a figure gallery, and this is the ugliest figure in the figure gallery. Let's see, what else? These are some example things. We were going to share the slides. So I said that I'd hand it off to Josh when I got to the data, and so here's the one joke in the slide.
Right. Okay. All right. So I'm going to take you through some of the, put a little bit more, so Rich has been talking about the infrastructure we've been building and sort of the idea behind the lab, bringing people together. I mean, and I do want to just say one word on that. I mean, this is amazing. I'm up here giving a talk with someone who's, trained as a biologist and a computer scientist. I'm trained as a political scientist. It's really exciting, the opportunities here, but the challenges of this stuff, and Rich has just been getting at some of them, there's technical challenges, there's conceptual challenges, theoretical challenges, all these things are enormous, and it really is a kind of exciting time for doing kind of cross-disciplinary research and getting people from different groups together, which the center here, I think, is very well aware of. So what I want to do is take you through, just put a little meat on some of these bones here and give you some quick examples, and then we can come back and talk with if people are interested more about the project. So we've got, as we said, we've got 3.5 billion tweets, and as Rich showed you, these originate out of things that people think would be interesting to study. So we have all sorts of collections from international events that have been going on, and basically our international data is sort of reaction to protests. So we've been collecting, when there are big events internationally, we've been collecting data as quickly as possible as we can. There's obviously, when thinking about automating these methods, this is a long-term goal, right? Obviously what you want to get is before the protest starts so you can watch. So we actually now have an incredible opportunity, because we started collecting the Je suis Charlie data immediately after, I mean, this is an unfortunate thing, but we started correcting it immediately after the event happened, and then 5 days later there's a protest, and there's so many people at that protest that we actually have hundreds, if not thousands, of people who we can geotag already as having been at the protest. And this is the first time we have data from before, the days before, and we can actually go back before and look what people were doing previously. Then we have a lot of stuff that's been data from social media in the United States, and the US has been more planned ahead of time, where we've been thinking about collecting things that are going to be big issues in election campaigns. We've also been tracking all members of Congress. We'll sort of set up before the State of the Union, before things. So we have these sort of two parallel tracks going on, with the US stuff being sort of more regularized political participation, the international stuff being more protest-oriented. We have lots of different papers that are going on throughout the lab. We try to put drafts up of these on the website as quickly as we can as people work on it. But as Rich said, it's we're trying to bring the lab model from the natural sciences to the social sciences via this kind of cross-disciplinary collaboration. So the idea is get lots of grad students together and postdocs and people and sort of empower them with these tools to do sort of interesting research within the general theme.
With one exception, we have a lot less money.
Yes, we have a lot less money than the natural sciences have, so we're trying to do it all on a shoestring. Although, for the political scientists in the room, we have a lot more money than political scientists. Okay, so I'm going to show you things from 4 of these projects right now, just to give you a flavor of the kind of things we're going to do. And in 15 minutes, I'm not going to give you theory, hypothesis, data in a sort of normal talk. I just want to show you some of these tools applied to some of the things we're doing, so you get a sense. So these are the 4 things I'm going to talk about here. Let me begin with polarization in U.S. politics. So here's a slide you don't normally see in a political science talk. What we're able to do here, this is Retweet Networks from the 2012 U.S. presidential elections. And one of the grad students in the lab, Pablo Barbera, developed a method of estimating ideology of Twitter users based not on the content of their tweets, but on the networks that they're in. And he's got a wonderful paper that just came out in Political Analysis that validates this method over every single kind of data you could imagine, over nominate scores, over state polarization, all sorts of things. So we get estimates of users. And this shows you the sort of what the retweet network looks like of people tweeting about, the keyword searches here were Obama and Romney. This is a sample because, as Rich said, building these networks up can be very inclusive. So this isn't the whole data set, but it's a sample. And what you can see is that around the time of the 2012 elections, we have this very sort of polarized world where, people on the left are retweeting almost exclusively people on the left, people on the right retweeting much more on the right. But this gives us a really interesting opportunity to look at variation over time in these kind of polarization networks and variation over issues, right? One of the questions of the internet is whether the internet's an echo chamber or the internet is sort of pluralism writ large, right? Is the internet the great democratizer or is it the great echo chamber? And so we can use these data to sort of get at this. This makes it look like the great echo chamber talking about the election. As we move into the sphere, then we can do this for foreign policy. So we collected stuff so we did State of the Union, still big red and blue blobs. As we get into a foreign policy topic, Syria, you see it starts to get a little bit less distinct. Then when we go to some of our control data sets, we've got, this is the Super Bowl on the left, right? And it's completely disappeared. So over the time we get to the Super Bowl, people are tweeting all left and right. I mean, it's bluish because the blue dominates the red color and because we had more liberals in the data sets.
Because you plot the blues
after. And then, but you see that blue and red clumps have completely disappeared from each other. This is the Oscars on the right, and the interesting thing about getting involved in data science is that this has now got me giving talks sometimes where there are astronomers in the audience. So at this point I point out, here's our overlap with astronomy. We've actually got a black hole in our data set, and this is Ellen DeGeneres during the Oscars. This was her selfie that went completely viral, and it has the same properties as a black hole in the middle of our data. Another way to look at this data is that we can think about heat maps, and this gets into the social psychology about whether liberals are probably more likely to retweet conservatives, conservatives more likely to retweet liberals, but we can also look across different issue areas. These are heat maps that are basically showing the retweet networks by our estimates, the same sort of thing I was showing you back here, where we have people who are estimated to be more to the right, people estimated more to the left. Now we can see which kind of retweet networks are going in. And on this graph, I just draw your attention mainly to the fact that we're getting these clumps in the upper right and the upper left-hand corners. And so that's more liberals retweeting liberals and conservatives retweeting conservatives. That's another way to display the data. Then with this, we can just sort of, this is actually just making this data even, taking it away from this sort of dimensional plot, bringing it down to a sort of a simple number, which is the average absolute distance between the ideology of the retweeter in the center. But you can now start to look across issues, right? And what we find is exactly kind of as we expected, like the Super Bowl, the Winter Olympics, these have the lowest levels of polarization.
The government shutdown, State of the Union, these have the highest levels of polarization. So, I mean, this is not shocking. No one's going to be shocked by this thing, but it's a demonstration of the kind of tools that we can use and the kind of questions we can start asking with this data, which is not, reliant on survey data. This is actually from hundreds of millions of tweets. Here's another topic we've looked at, one of the big questions in the recent Euromaidan movement in Ukraine. This is obviously a huge issue now in the international politics, but one of the questions when the original protests arose, which now has actually a very big connotation for what's going on with Russia and Ukraine, was this a sort of Russian versus Ukrainian speakers type issue? This has been a big thing from the start. Or was this originally Ukrainians who were sort of dissatisfied with corrupt government and were trying to rise up against a corrupt government and replace it with something? Was this more about moving to Europe? Was it about Russia versus Ukraine? So, previously, if we wanted to get at language usage by protesters, what would be the tools at our disposal would be sort of participant observation, maybe some ex post surveys asking people what they did. But now we can actually look at all these people who were using social media to communicate during these protests. So we're doing actually a lot with these data, but in this particular case, we can think about whether or not there's a language dimension to the protests. Is it sort of Russians talking to Russians on social media, Ukrainians talking to Ukrainians? So one of the things that we can do is we are looking here at this particular graph. This is Twitter usage by people, and this is one of the cool things about Twitter. You have to pick a language to download the interface. So we can get this behavioral measure of someone's preferred language as opposed to asking them in a survey question. So we can actually see what they downloaded. Now, there's some technical issues, which I can talk about later during Q&A, about why there might be operating systems benefits to different languages. But for the moment, just bear with me on this. This is a graph of people who downloaded Twitter in Russian, right? The interface is in Russian. And we can see tweets that are going on in the reds are tweets in Russian, the blue are tweets in Ukrainian, the green are tweets in English, and gray is tweets in the other language. These are proportions here. Well, two things immediately jump out. One thing is, people are tweeting in both Russian and Ukrainian, right? If we had expected this to be a situation where it was completely polarized, this figure should be all red. The other thing, which sort of presages perhaps where things went afterwards, is as we got closer to this is when Yanukovych flees, and we go to immediately thereafter enter the new phase, which is the Russians going into Crimea. But we do see an increase in Russians using Russian. Now, this may be idiosyncratic, but it's an interesting thing to keep an eye on. Same thing with Ukrainian, people who downloaded in Ukrainian. And for technical reasons, we're really pretty confident that people who download in Ukrainian do this because Ukrainian is their primary language. But again, you see, it's not just a mass of blue, right? It's blue and red, and Ukrainians are tweeting in Russian. There's a million interesting questions that we want to ask here. Interestingly enough,
these
this
are
increase.
separated by their geotags.
These are people from our Ukraine collection. This is not separated by geotags. This is separate. These are people who are tweeting about Ukraine who listed Ukraine and Russia as the primary language that they did this. Yeah, so it's possible that we're getting some people in the diaspora here. In a more recent iteration of this, we're working much harder to sort of limit this purely to Ukraine, but there's not a lot of people who put down Ukrainian as their primary language who are outside of Ukraine. We can look another thing here. This is a picture of Retweet Networks on February 18th. This was the day of the worst violence during the Ukrainian protests. 25 people died on this day. And this is a measure of the Retweet Network. Again, going back to what Rich was telling you about the infrastructure, we built beta done a series of keywords that people were using to talk about this, right? And obviously, the shape of this picture it's a forced layout algorithm. We could make the shape look different. But what I want to show you what we can do with this is, we can look at this, and then we can break this network down by language, and we can see, is part of this all Ukrainians retweeting Ukrainian language tweets or Russian tweets being retweeted in Russian tweets? So here's the whole network. Here's the Ukrainian tweets located in this part of the network. And here's tweets that are in Russian located in this part of the network. So we can see a couple things here. One, these pictures are different from each other, right? There are some areas, there is something distinctively going on about Ukrainian language tweets and Russian language tweets. This huge area up here, by the way, ends up being this is mainly English language news media that's going, this is mainly stuff going on in English. But we can see that on the one hand, there are some things different, but on the other hand, there's this huge area of overlap between these two. Again, it's not this picture is the Ukrainian and this picture is the Russian, right? So we're learning some stuff. We have to continue to refine our methods, but it's a kind of, as a first cut, it's an interesting take on what's going on as people are discussing these protests. Okay, here's another use that we've done. This is from one of our grad students, Kevin Munger, who's been working on this. And this was a paper about trying to test a formal model of elite action during times of crisis, where the idea behind the model was that opposition elites should want to focus in on the crisis moment, and that government elites might want to dilute the information space by talking about lots of other things and making it harder for people to coordinate on the issue that's being raised by the opposition. So this was an attempt to take formal theory and then see, could we look at this? So what we did was we built a data set. We got every single Venezuelan member of parliament that we could find who had a Twitter account. We broke them down into opposition elites, and we broke them down into the government elites. And then these vertical bars here are the time periods, and this is sort of before the protest escalates, when the protests are escalating, the main part of the protest, and then after the protests subside. And what this is this is interesting. So what we do is we take all of the tweets by all of the members of the parliament, and then we broke them down using LDA, which was talking about this the unsupervised methods of topics, to just break them down into 100 different topics. Now, we weren't interested in whether we identified substantively meaningful topics from doing this. What we were interested in saying was how much were people sticking to some small subsection of these topics. Because the theory predicted that the government should not stick to them during the protest and the elite should. And we use this, and this was a great overlap between different fields. Rich suggested for the Shannon diversity measure, the Shannon entropy measure, which we were not aware of in political science. And we use this to sort of get a sense at how congealed these topics were, how much were people sticking to particular topics. So the opposition, this looks exactly like what you would think. They were kind of talking about lots of different things. The protests start. This is the series of protests in Venezuela in 2013. The protests start, and they really kind of get on message. And then once the protests are over, they kind of go back to talking about a lot of different things. Here's the governing elites. They do what the theory predicts, and they sort of look very different from the opposition elites. So this is another thing you can do. And one of the things we've discovered, we applied for this grant to study mass behavior. Twitter and Facebook, these seem like the mother of all cross-sectional time series data sets for measuring political behavior. But it turns out to be these really interesting windows into elites. And a final thing, which we're running pretty short on time, final project that we're working on is we're trying to come up with seeing whether we could have predicted the votes of members of Congress during the government shutdown a year ago, last fall. Remember the government shutdown, and the Democrats all stayed together and voted to reopen the government. The Republicans originally voted not against the budget, and then a bunch of them defected 13 days later and said that, or 18 days later, and defected and voted to reopen the government. And what we wanted to see was whether we could predict this from the text of their tweets. So could we use models? So we used some supervised models to try to do this, and we got some division here. If you can see, this is a graph based on nominate scores, but you can see there's sort of some, the Democrats it predicts very well because they all vote one way, but there's some division between the yes Republicans and the no Republicans. But here's a really interesting thing.
Ideology doesn't do it.
Well, no. What we're going to do here is we're using what we do here. Yeah, no, ideology does a very good, we use for ideology measures, we use these nominate scores, which are these roll call voting based ways of trying to understand whether or not we get the positions of members of Congress on an ideological scale. And what you find is that for the no Republicans, this is just the Republicans. Yes, when you use ideology, you do a great job of predicting no Republicans who don't defect, because the only ones who vote no are the Republicans. But when we look at the Republicans who break ranks and who go with the Democrats, right? This is how well we can do predicting them based on the nominate scores. But this is how well we can do predicting them based on their tweets. And this is how well we do with tweets plus nominate. So you actually, this is the first time we found this, we were really excited about this. You actually get an improvement in prediction looking just at the text of what these people were, of what they were saying, than you do over looking at their ideology scores. Now, there's a lot of other reasons why maybe ideology would or would not predict this, but this is another sort of exciting direction that we've been looking at, something we're trying to get a sense of from elites. And this is completely unsupervised methods, and we have some, breaking them down into categories and using, this is all based on the text of their tweets. We're still a long way away from being really confident that we can do this. This was one issue. But we got some breaks that were kind of interesting, and we did get, so this is the Democrats who vote, it breaks it into three categories. This is obviously the Democrats who are voting to keep the government open. The interesting thing is that this middle category, right, this is the category of Republicans, the middle category does have a higher proportion of yes Republicans than it does have of these no Republicans. So this is trying to use unsupervised methods to break it down into three classes. So Anyway, those are just little bits and pieces of lots of different projects. As we said, there's lots of people that go into doing all this, so we'll just thank a lot of people. These are the students and the faculty who've worked on these various projects I've showed you today. We have an ever-growing number of people who are there. We're really excited about what we're doing, but it's still very early on in the day, so it's great to get an opportunity to talk to other people who are thinking about these kind of issues, to hear what people are doing, and to share a little bit of what's going on with our lab. So thanks very much, and we're looking forward to whatever questions and discussion you have. Thank you.